Hi everyone, my name is Kari Liram, and in this video I'm going to provide an overview of the scientific method of controlled experiments. Now, as humans, we're naturally curious about the causes and effects of things. We want to know, particularly when there's something wrong, if there's a social problem, what's causing that problem, right? So we want to know what the cause is so that we can maybe eliminate that cause and thus fix the problem. But the problem is, how do we know if one thing is causing another, or if the two things are discorrelated with each other, or if it's the reverse, the other thing is causing the first thing? In order to do this, we have to do a few things. We have to first see that there's an association between two things. Then we have to determine the direction of the influence, which one is causing the other, impacting the other, or are they really just hanging out together and neither are causing the other? And you have to eliminate plausible rival explanations. And the best way to do this is through a controlled experiment. This is also referred to as a true experiment, and in the case of medical sciences, a randomized clinical trial. In natural sciences, controlled experiments are usually conducted in labs. In social and health sciences, controlled experiments are also conducted in natural settings, also known as field experiments. So the criteria is we start with a testable if-then hypothesis. Identify your primary independent variable. The independent variable is the cause of the thing that you think it's going to cause something. Independent variable is the thing that you think is being affected. I'm trying to explain the effect. Then you carefully select a pool of participants, and then you randomly place them into two groups, one experimental or intervention group, and the other one, the control group. Then you manipulate the independent variable for people in the experimental or intervention group only. And you do nothing for the time being to manipulate people in the control group. After the independent variable is manipulated in the experiment group, but not the control group, then over time, after time passes, then you measure the dependent variable for both groups. If there's a difference between both groups, then you test to see if it's statistically significant. Okay, so I'm going to talk through this through an actual example of a controlled experiment. This is an experiment on circumcision and HIV that happened in South Africa in the early 2000s. Now, if you remember back to my video on inductive and deductive research, I did that a few years ago, it's on YouTube. I talked about the research wheel of starting off with observational, sort of just observations, that's inductive research. Once you do a lot of observations, then you can start to see patterns, and then you can maybe start to create some hypotheses, and then you get to a point where you can test the hypotheses. So this is where we are here with this experiment. You can see here, it's a quote from this article. Observational studies before the experiment happened were suggesting that male circumcision seemed to provide protection against HIV. A number of observational studies showed this, but they were not able to conclude that there was a causal effect. In order to do that, they had to have a controlled experiment. Okay, so the independent variable here is male circumcision. The dependent variable is HIV status. The hypothesis can be written in an if-then statement. If men are circumcised, then they will be less likely to contract HIV. Okay, moving on to the second criteria of experiments, you create a pool of participants and then you randomly assign them to two groups. So you screen in and out participants, you ensure that they're starting from an equal place of inclusion criteria. In this experiment in South Africa on circumcision and HIV, they had to be men between the ages of 18 and 24. They had to wish to be circumcised. They had to live in a particular area, and so on. After the pool was created of like-minded and embodied people, then they placed them randomly into one of two groups, experimental or control. After they did that, they also had to check and match to make sure that other variables, which might be impacting the dependent variable, were the same across both groups. So they had to double check there. So things such as age, education level, religion, ethnicity, alcohol consumption, those all can also impact the dependent variable of HIV. So they had to make sure that those were equally distributed across both the control and intervention group. And indeed they are. Statistically, there are insignificant differences between both groups. Okay, so now we've got two groups, they're the same. And now you manipulate the independent variable just for the experimental or intervention group. So in this study, we have a total of 3,274 uncircumcised men. At this point, by the time the study was going, they weren't just 18 to 24, they had aged into 18 to 25. They were randomized into a control group or an experimental group. Participants in the experimental group were offered circumcision right away. Participants in the control group were not offered circumcision until after the study, and I'll talk about that in a second. They had follow-up visits over time, so you have to watch it over time. At these follow-up visits, the participants were in both groups were tested for HIV, so they all started off HIV negative, tested each time. In order to control for other factors which might be impacted the dependent variable, additional factors, they also asked participants, what have you been doing in the last 3 months, 6 months, whatever? How many partners have you had? How much sex have you had? How many, etc. These sorts of things which also might impact the dependent variable. Okay, then halfway through the experiment, researchers were already seeing a very strong evidentiary base that the independent variable circumcision was indeed having a dramatic impact on the dependent variable, HIV rates. So the experiment ended early because it would be unethical to continue, like they did with the Tuskegee syphilis studies. You have to stop once you can see the evidence and give people in the control group the option to also get the intervention, in this case, circumcision. So here are the results. The intervention group, the newly circumcised group, did have 20 new HIV infections during this time of the experiment. So circumcision did not prohibit HIV from happening. So it wasn't 100% effective, obviously. However, look at the control group of uncircumcised men. They had more than double the HIV infections. Remember, they were controlling for all these factors simultaneously. So they concluded that circumcision in and of itself was able to provide a protection of 60% against HIV, which at that time was really remarkable. Cause for a lot of celebration and, wow. When controlling for other factors that could impact the dependent variables, such as sexual behavior, condom use, other sorts of things, protection against HIV for those in the intervention group actually rose to 61%. So I'm going to step back here a couple of steps and talk about some pros and cons of controlled experiments, and I'm going to keep talking about this particular experiment as I do so. So controlled experiments tend to be very high in internal validity. This is the idea that you have confidence that what you're measuring as the independent variable is impacting the dependent variable. An experiment is internally valid to the extent that it can rule out the possibility that other variables, other than the thing that you're manipulating, is responsible for the dependent variable. So airtight experiments can establish a strong inference for direct causal relationships. Remember, we can never prove anything in science. We can establish strong inference, though, the strongest influence possible when we're talking about controlled experiments for causal relationships. There are at the same time a number of cons or drawbacks from controlled experiments. They are typically lower in external validity. So just as they are higher in internal validity, they are also lower typically in external validity. And this means how generalizable are they? Would the experiment produce the same results with other people and in other places? In the case of circumcision and HIV, we can see that the connection can vary considerably, for example, depending on the cultural and socioeconomic context. So for example, men in Mexico and Sweden have relatively low rates of circumcision, and they also have relatively low rates of HIV. So obviously something other than circumcision is impacting HIV in those two settings. Because of all these variations of variability, we need to, for external validity to be strengthened, it does need to be replicated in a number of different settings with a number of different kinds of people. And in these sets of clinical trials with circumcision and HIV, they were replicated 3 times. There was the study in South Africa that we were just talking about, Uganda and Kenya, and they all produced similar results. The intervention was then offered or talked about being offered in sub-Saharan Africa. However, in order for the intervention, whatever it is, to be offered globally, then obviously you need to have a much more scaled up set of experiments that can take into account all these different kinds of variations. And this is indeed what's required before offering intervention to the global public, such as vaccines. A couple more cons of a controlled experiments. One is that they have high reactivity and social desirability effects. And in other words, people behave differently when you know you're being watched. For many of us do anyway. Being in an experiment, you're being watched very carefully. There's also a number of very serious ethical concerns that come up, in particular with experimental methods, because abuse of power can be more likely due to these extremely controlled conditions. I did a video, again, you can see it on YouTube, on ethics in research, where I talked about, some very famous abuses of power with the Tuskegee syphilis experiment, the Nazi regime experiments, the Zimbardo experiment, the Milgram experiment. There's many examples. In this case, the case of circumcision and HIV, the trials were approved of by rigorous IRB processes from a number of different countries, but they still had some serious ethical concerns. Some people had some serious ethical concerns. And you can see the end of my video for recommended references on this. Now, there are also many times when experiments are just not feasible. As satisfying as it is to establish strong inference for a causal relationship, in many cases, when looking at social problems, controlled experiments are just not possible for ethical and also practical reasons. For example, many people want to know, what are the causes of and solutions to mass murder? We have a lot of observational studies from a lot of different, sort of comparative analyses that it seems like places that have high access to semiotic weapons also have higher rates of mass murder. But you can't do an experiment on this, right? Because you can't manipulate ethically that independent variable. You can't give some people access to semiotic weapons and then others not, and then just watch to see which one commits mass murder more. So a number of cases like this. Another one is you want to understand the causes of and solutions to homelessness or houselessness. We know that correlational studies, we can see that places that have a lack of access to affordable housing also have a high rate of houselessness. Can't do an experiment on this because you would have to manipulate the independent variable. You can't give some people access to affordable housing and then take it away from other people and then just watch to see if they become homeless or not. But fortunately, there are many other empirical methods to help us see these correlations and envision possible potential causal relationships. And that's where most of us have to land because of this inability for ethical and practical reasons to actually experiment on people. So we have macro level comparative analyses across populations and countries, meso level analyses of the impact of different kinds of programs or policies, micro level analyses of interviews of people. All of these can be you can have statistical analyses, which can sort of statistically control for different variables. It's not the same as actually literally controlling people, but it's the best that we can do. So in conclusion, controlled experiments are seen as the gold standard for empirical research because they can observe causal relationships or strongly infer causal relationships. But for ethical and practical reasons, maybe most human-centered concerns cannot be observed through experiments. Fortunately, we have many other research methods available, and ultimately all of us need to rely on a combination of methods and epistemologies to really understand anything. I'm going to leave you with the referenced experiment here that we talked about on HIV and circumcision in South Africa. There are also two articles here that discuss, analyze, and critique all three of the experiments that happened in South Africa, Kenya, and Uganda. That's it for me for now. I hope that this was helpful for you, and I'll see you next time.